Well, aloha everyone, and welcome back to Anatomy 151 here at Chaminade University. Today we'll be investigating Unit 11. We'll be talking about skeletal muscles, how they produce motion, and the specific skeletal muscles and the location on the human body. So skeletal muscles allow the body to move, and they do that by exerting force on tendons. So tendons are a particular structure that attaches to both the muscle and the bone, and when the muscle contracts, the tendon then pulls the bone, and that allows motion to occur. Now, muscles have both an insertion and an origin. And basically, the origin is the region that attaches to the bone that remains stationary during whatever the motion is. And the insertion is the region that attaches to the movable bone. So if, for example, we're looking at the biceps muscle, the biceps muscle is going to run all the way up from the scapula here. So that's going to be the origin. The scapula is not going to be moving in this case when we are actually going to be pulling here on the radius, which is going to lift up the lower arm. So the origin is going to be found again up here at the scapula, and we're going to have tendons that connect that all the way from the scapula to the biceps muscle itself, biceps brachii. And you can also see the larger part here. This is called the belly of the muscle. And then that's going to have another tendon on the other side, which is going to attach to an insertion site on the, in this case, the radius, but on whichever bone is going to be moving. Right? So basically what happens is that muscles cross a joint and attach to a bone on the opposite side that articulates with whatever bone it starts with, the insertion site, the origin site, and then the muscle contracts and draws the articulating bone towards it. And this comes down to basic physics. So bones serve as what's called a lever, and if you're not familiar with levers and fulcrums, let's talk about this for a second. So basically the joint, or whichever the region is that's moving, that's where two bones are going to articulate, that's going to serve as the fulcrum. And the lever is going to be the bone itself, and then we have two different things that can act on the lever. In this case, we can have resistance or effort, and these are going to be kind of working against or alongside each other. Now, here we have them denoted over here in the key as E for effort, which would be a force, basically. In this case, the contraction of what we were just talking about, the biceps. We're going to stick with that. So when the biceps contract, that's considered an effort. That effort is going to act on the actual, here's the fulcrum, right? It's going to have the elbow joint pulling up this direction, which is going to be opposite of the load. The load would be considered the weight of whatever the object is, plus, of course, the weight of the forearm itself. So the effort is going to be acting basically against a load to be able to pull it up, or if it's working, say you're slowly relaxing, it can be working in the same direction as the load. So they're all going to be working either one way or another in order to cause the bones to move. All right, so we have multiple different types of levers, and all levers are going to involve the effort, the fulcrum, and the load, right, or the weight. So where do we have to exert effort in order to move the load across the point that's considered the fulcrum? And we have multiple different types of that, and all of those are depicted in the human body. Here's an example of a first-class lever. And the difference between the first, second, and third-class lever is basically the location or relative location of the effort, the fulcrum, and the load. So a first-class lever has the fulcrum right in the center. When the fulcrum is in the center, the effort, for example, going down can cause the, we'll be cutting through a paper, because in this case it would have weight going that direction. And that's kind of depicted here in your neck muscles. And the fulcrum would be your cervical vertebrae. And the load would be the weight of your head up and down, right? So this is, the effort would be exerted in this direction, the fulcrum would be in the middle. That's a first-class lever. A second-class lever is when the fulcrum is at the very front, and like a wheelbarrow, the effort lifting upward, and the load would be the weight that would be in the middle of the barrel. And then an example of how that works similar in the body. So a second-class lever example in the body would be if you were to raise your ankle and foot joints, the effort would be exerted on this muscle here by contraction. That contraction and the load would be, of course, the weight going downward, and the fulcrum in this case would be on the toe, right? So this case, the fulcrum would be in the forward part. And that, again, is an example of a second-class lever. An example of a third-class lever would be like a set of tweezers, for example, where the fulcrum is at the very far side, and the effort in the middle, and the load on the outside. And what's the difference between this one and that one? Yes, the fulcrum is on the edge on each side, but in this case, the effort is on the outside, and the load is on the inside. In the case of a tweezer, the effort would be on the inside, or you'd be squeezing here, and the load, if you were to carry something in there, would be on the opposite side. An example of a third-class lever in the human body would be the elbow joint. Here is the example we were talking about previously, where we have effort at the contraction of the biceps. The fulcrum is shown as the actual joint itself, the elbow, and the load would be the weight of whatever you were carrying in your hand plus the weight of the forearm itself. All right, so we can have different types of levers situations. We can also have different types of fascicle arrangements. So the muscle fibers themselves are arranged in parallel bundles, but the arrangements in relation to the tendon can vary. So the way that they are actually attached to the tendon can vary. And the way that the fascicular arrangement is located within the muscle, it can be correlated directly to two things. One, the amount of power that the muscle is able to produce, so strength, right? And then the range of motion that that muscle can produce. So some different ways that we can have these arranged. We can have them parallel. If they're parallel, they're running longitudinal to the axis of muscles, and that's terminating on either side in flat tendons. An example of that is the sternohyoid muscle. We can also have fusiform, which is similar to parallel, except we have a bit of a bulge, so the muscle is going to taper outward and then back downward towards the tendon, where so the diameter is actually going to be a little bit less at the tendon than at the belly. So the belly is wider. An example of this, the digastric muscle. Circular muscles are just as you'd expect. They're going to be a circular arrangement of the fascicles. So for example, a sphincter muscle that you might want to contract. Or the eye muscle, the orbicularis oculi muscle. All right, another arrangement is triangular. If they're spread out over a broad area where we have one tendon, that's going to give a triangular appearance. An example of this would be the pectoral muscle, pectoralis. We also, not only can we have the arrangement of the fascicles is something that we can look at, but we can look at how they are aligned on the tendon. So if they're only aligned on one side of the tendon, that's called unipennate. Or bipennate would be if they have it on both sides of the tendon, more like a feather. And if we have multiple sets of tendons that are going to come out from one central tendon, right? That's called multipennate, and that's an example of something like the deltoid muscle. All right, so muscle motions are coordinated. Generally, we have muscles that are going to be equal and opposite. And so skeletal muscles generally act in groups, not just individually, and they're arranged in opposing pairs, usually at the joint, right, or the fulcrum. So you usually have one that is the actual prime mover, that's considered the agonist. And then you have an antagonist that's kind of the equal and opposite. So if you were to picture lifting your hand up, at the same time you have one that's holding it so that your hand isn't going all the way up so that you're able to then lower it back and forth. So we have one that's the prime mover and one that's the antagonist or the opposite mover. And then of course we also have the synergist movement. Muscles are named in multiple different ways. One of the prime ways that they're named is based on their location, but also on their size, right, majora or minora, right? Also the number of origins, the appearance, the direction of the fibers, and where the origin and insertion sites are, and last but not least, the muscle action. So what does that muscle do? Does it lift? Does it lower, right? So depending on which direction it moves, it can have a different name as well. So this is a list of the different characteristics that are used to name muscles, and basically this is just a list of definitions. So these might be new words, but if you look at them, they all have their own definition. So the word rectus simply means that it runs parallel to the midline, as opposed to transverse, which runs perpendicular to the midline, right? So we have two different sets of abdominal muscles, for example. The rectus abdominis are going to run parallel to the midline. It's your six-pack, for example. And then the transverse abdominis are going to run vertically, right, perpendicular to the midline. The oblique would be something that runs in a diagonal, and an example of that would be obviously the external oblique muscle. So basically, anytime that you're reading these, what you want to be translating them into is what do these words mean, which helps you define both where they're located sometimes or what size they are, perhaps. For example, maximus minimus, right? The maximus would be the largest, gluteus maximus, gluteus minimus would be the smallest of the glute muscles. Or whether they're long or short, so longus, brevis. Latissimus means widest, longissimus means longest. Magnus, large, major, larger, minor, smaller. Vastus means huge. You can also have them defined by the relative shape. So if they're deltoid, they'd be triangular. Trapezius would be trapezoid. Something called serratus would be sawtoothed. Rhomboid means diamond-shaped. Or circular would be like the orbicularis that we were talking about in the eye. Pectinate means it looks kind of like a comb. Piriformis looks kind of like a pear. Platus would be flat. Quadris, of course, square, and then gracilis means slender. So these are basically just definitions of what this muscle looks like, or the relative size or the orientation of the muscle. We can also name the muscle based on its action. So does it flex or extend? Or basically, does it change the joint angle by decreasing it or increasing it? Does it move the bone away from or closer to the midline? So if it's an abductor, that means that it moves the bone away. If it's an adductor, it moves the bone closer. Levator raises, depressor lowers, right? Supinator would be something that turns, for example, turning your palm anteriorly, or protonator, the opposite of that, turning it posteriorly. A sphincter would be something that decreases the size of an opening. Tensor would make a body rigid, part of the body rigid, and a rotator would be something that rotates. So these words, although they might seem foreign, once you realize what their definition is, they're basically just defining exactly what they do or where they're located or what kind of shape they have. If you see something like bi, tri, or quad, that tells you how many different origins. So biceps has 2 different origins. Triceps would have 3 different origins. Quadriceps would have 4 different origins. So these are different ways in which we can classify and identify different skeletal muscles. Now, this slide, and I'm going to jump forward just one, and this slide, these 2 slides are going to be the slides that you're going to want to spend the most time and attention on. Any one of the muscles that are listed here are going to be fair game for the exam, and while I'm going to walk you through them, once is not going to be enough. You're going to have to go through this. This is when I would recommend, if any of you have gotten that anatomy coloring book that I talked about earlier in the semester, this is where that would really come in handy. Anatomy coloring book and some colored pencils where you make sure that from every direction you use similar colors for the same muscles so that you can repeat it in your brain over and over and over. So that you can kind of burn in which of these muscles is which. But I'll get started in running through them with you just as an overview. If we're starting from the top to the bottom, this is an anterior view, right? So we're looking from the front of the individual. The frontal belly here is the occipitofrontalis. The epicranial aponeurosis is the one that runs along the top. Then we have the temporalis that runs along the temporal bone. Nasalis, that of course runs across your nose. Orbicularis oris. Here, it's actually going to be part of your mouth line, but it's going to run and be responsible for kind of like your smile. Orbicularis oculi, that's going to run around your eyes and allow you to do something like squint or bring something into focus a little bit. Masseter is going to be a muscle that's going to be part of mastication or chewing, so the ability to chew and swallow. It's going to be your jaw muscle, essentially, allowing you to lift and lower your jaw. As we run down the neck, on the outside we have the plasma, and then as we go underneath that we have the sternocleidomastoid. Running down along the neck and into the shoulder, that's the trapezius. Inside the neck further we have the scalenes. That runs as far inside. That's actually all going to be hidden, so you can see this has actually been removed over here. As we go further down into the arm, we have the deltoid. That's here. Then the pec here, the pectoralis major. The serratus, that's here, serratus anterior. Serratus, of course, means sawtooth, and we're going to have these on both sides, but we're just basically, so that they're not overlapping, we're running through one, I'll run through the other side next. Going down the arm, the biceps brachii, that's the one that we discussed very early when we were talking about the early stages of how a lever works. Then we have the brachialis, which runs along the outside. The triceps runs along the inside and towards the back. The protonator, which does exactly what you think, it allows for protonation. The protonator teres, that runs in here. On the outside, in this position, we have the brachioradialis, which runs along the radius. Then we have the flexor carpi radialis, runs along that similar region, allows you to move your palm up and down, right? Move your fingers. The flexor digitorum superficialis does pretty much exactly what it says. It allows you to flex your superficial, the superficial line of your digits, right? Then we also have the flexor carpi ulnaris, which runs along the ulna. As we run into the hand, we have thenar muscles and the hypothenar muscles that are going to allow us to move our digits. All right, coming back down this side again, we have the, I just talked about it, I touched on this, right? Okay, so we got here. So the omohyoid is going to be a muscle that runs right here along the same region of the hyoid bone. The hyoid bone is the only free-floating bone in the body that's not connected to any other bone. The sternohyoid is underneath that here, and that's going to run along that direction. Latimus dorsi, it's your lat muscles in here. Rectus abdominis, that's these guys here. They're going to be your abdominal muscles as we consider your six-pack. The brachioradialis we talked about on the other side, that was here, but here we're showing it here as well. External obliques on the outside of your torso. The tensor fasciae latae that goes out here. Uh, Iliacus goes in the iliac cavity, so inside where your iliac region would be of your body. Psoas major, that's over here. Pectineus runs down your leg. That's one of the larger muscles in your leg. It's actually going to be kind of hidden, but that runs down this direction. Adductor longus, another one where you're defining it by its name, is actually going to tell you what it is. It's a very long muscle that performs adduction, right? That's here. The sartorius muscle connects from there all the way across, so it's a very important muscle. Rectus femoris runs along the basically where your femoral artery would be, and it's involved in keeping you erect. That's why it's called the rectus femoris. That's how you can stand, essentially. So that's when you're walking around, you basically got this flexed all the time. Following down, the quadriceps are here. They're going to have tendons that are going to connect at the patella region, which would be your kneecap. And then as we follow down, we have the gastrocnemius here in the back, the soleus, and the tibia. I apologize, my mouse has a little bit of a delay, so I'm trying to allow it to catch up. We also didn't cover some of these muscles on that side, so some of the muscles of the lower leg that we didn't cover on the left, I'm going to cover over here. The iliotibial tract, right, which connects which runs along to the tibia, of course. The patellar ligament, which is going to run alongside and connect to the patella, and then the tibialis anterior runs along the tibia, right there. This is the tibia bone, just for reference. And then the fibularis longus, which is a long muscle that runs along the fibula. So you can see that a lot of these they're either described by their size, their location, or what they do, and sometimes a combination thereof. All right, so I just walked you through it once, but this is something that you're going to want to go through several times because any one of these muscles are fair game for the exam. All right, taking a breath, we're going to move on to the posterior view. Again, we're going to start at the head and we'll work our way down. Here's the epicranial aponeurosis, runs along here. Temporalis, again, that runs along the temporal bone. Sternocleidomastoid, that's going to run along the neck. The splenus capitis runs inside the neck as well. Trapezius is going to connect up to the top of the head and over to the shoulder, right? We also have the deltoid. Deltoid muscle connects here, back of the arm. Brachialis is depicted on the side, the very edge of it's being able to be shown here. Here's the triceps brachii, which we're seeing. If I go forward one, it was seen right there, but only the very beginning of it, only a little piece of it. Here you can see it runs along the back of the arm. And it said tri, so there's 1, 2, 3. So it's going to have 3 separate sets of tendons that connect. We also have the anconeus, which runs, come on, right along the back of the elbow, right, and you can only see some of it because it's going to be underneath the extensii carpi, radialis brevis, which is out here on the outside, and again, it does exactly what you think. It extends the carpus. The extensor digitorum is going to allow you to extend your digits. The extensor carpi ulnaris is going to allow extension on the ulnar side, right? So the ulna is going to run underneath that in terms of your bone structure. We also have the abductor pollicis longus. It's barely seen. It's a little guy right here. It's long. It's going to run a long way, though. It's a long. That's actually just depicts basically its size. Then we have the extensor pollicis brevis. Brevis meaning short, right along there. All of these are involved in the motion of the fingers. All right, I'm going to move back up and talk about some of the muscles that weren't covered on this side because they were, we don't want to have all the writing over covering each other. We have the infraspinatus that goes underneath this trapezius here. Right, we also have the teres minor and the teres major. Those all also kind of run underneath one another. These are all the muscles that overlay the scapula. We have the latimus dorsi. So we just talked about the lats in the front. If you were to roll around here, these are the latimus dorsi. You can see part of them, they're going to connect to the front here, to the region where, like, the abdominal region, where the abs connect. But they also are going to run all the way around and connect to the lower lumbar region of the spine. These are the external obliques. Moving down let's continue down the arm before we continue down the leg. The flexor carpi ulnaris, we already talked about that. That was over here as well. And the brachiradialis, which I don't think we talked about on this side, but we did talk about on the other view from the previous slide. All right, moving down the legs, here's the gluteus maximus. We're all pretty much familiar with this one. As we follow down the back of the leg, on the inside, we have the gracilis. You can hardly see it. It actually connects right down here. This guy right here is the adductor magnus. Adductor because it allows you adduction, right? The motion of adduction. Semitendinosus here. That runs right down this guy. And then this one here is the biceps femoris. Biceps meaning that it has 2 origin sites as opposed to triceps having 3. Iliotibial, that runs on the outside there. Come on, right here. Yep. Popliteal, anytime you see that, you know it's the knee. It's related to the knee, so it's going to be the muscle that's towards the back of the leg, behind the knee, the back side of the knee, the popliteal fossa. On the lower part of the leg here, also at the back of the knee, we have the plantaris, right? So that would be shown here on this side. All of these are going to be equal and opposite. They're just not depicted on both sides because there's not enough space. The gastrocnemius is going to be the back of the calf, basically. The soleus is going to be on one side and the other, but underneath of those. And then underneath of the gastrocnemius, the flexor digitorum is right here. It does exactly what it says. It allows you to flex your digits. It's the longest. It's because it's a very long muscle as well. Calcaneal tendon there is what's going to be connecting this gastrocnemius down to your heel. All right, so let's talk about some injuries for a second. So these are different things that can go wrong. Most of the time, the injuries that are sports injuries or running injuries involve twisting and turning or impact on the knee. So oftentimes the knee takes the brunt of the weight in these injuries. And this often is related to either faulty training techniques or just a kind of spur of the moment, odd landing, bad angle. If you land awkwardly on your ankle, it can travel up to your knee, for example. Oftentimes these injuries can be treated very easily with ice compression elevation or basic NSAIDs, right? Just ibuprofen. And more advanced treatment could involve steroid injections, corticosteroid injections, and rehabilitative exercises if it's found that surgical options are not necessary. Compartment syndrome occurs when we have a constriction inside a particular compartment of the muscle. And oftentimes what you have to have happen, this is something called a fasciotomy, where they'll take a scalpel and they'll just run it alongside the muscle and kind of break it open. So it'll break open the fascia so that the muscle can kind of pop open to alleviate that pressure. But if it's left untreated, it can cause nerve damage and blood vessel damage, and it can develop scar tissue, and it can end up with what's called contracture. So the muscle can end up kind of caught inside a contracted region where it's unable to function properly. Another example of a disorder is plantar fasciitis, which is a heel condition. And essentially what happens is the origin of the plantar aponeurosis at the origin of the calcaneus, which is the heel, can end up having a irritation that occurs over and over and over and can end up causing basically inflammation. And for this, again, treatment can include either heat or cooling methods like ice, stretching, rehabilitation methods, weight loss. Oftentimes this can happen with morbid obesity. Also prosthetics, sometimes you can have a replacement entirely, or steroid injections at that location, and obviously surgery could be an option as well. All right, so I told you guys that was going to be a pretty short lecture, but I do want to make sure that you take the time to focus on these two and also the ones that give you the nomenclature as well, so this slide as well. So make sure that you take the time to focus on those 4 slides and really know those slides in and out for the exam. All right, thank you so very much for paying attention to me today, and I will see you again next time. Happy studying. Aloha.